So today we're going to look at the graph of the first derivative and draw conclusions about our second derivative and our original function graphs. It's important to recognize some characteristics here of our first derivative graph. So we know where the first derivative equals 0, our original function, our OG function, so to speak, f of x, has critical points. And then we also know the second derivative is the slope of the first derivative graph. So that means that the slope of the first derivative graph tells us about concavity. All right. So from that we get concavity of f of x. And where f double prime equals 0, we have inflection points on f of x. And what do those look like on this graph? Well, that's going to be a critical point. On the f prime of x graph, the one we're working with today. All right, so bearing those things in mind, let's make our number lines for f prime, and f double prime. All right, so our function here, f prime, has x-intercepts only at -4. So that x-intercept, just like we said, is going to be do it in a color, a critical point on our original function, because that's where our output, our f prime of x on this graph equals 0. So f prime is the slope of our original graph. So we've got that guy. All right. Let's look now to say, is this the derivative positive or negative? So to the left of -4, we're down here, right, in the third quadrant, which has negative y values, or negative f prime on this graph. So that means we're going to be decreasing on our original graph. To the right of that, all of our values are in quadrant 1 and 2, or positive. So that means we've got positive first derivative, and we're going to be increasing on our original graph. Now let's look at the critical points of this graph, because remember, the critical points of this graph are going to be where our second derivative equals 0, and they're going to tell us about concavity, or our inflection points of our original graph. So we have those at -2 and at 2. So to the left of -2, our graph is increasing. Since the slope of our first derivative graph is our second derivative, that's going to, whoops, sorry about that. That tells me, all right, to the left of -2, I have a positive, yikes, because we're increasing, second derivative, and that on my original graph, that would mean I'm concave down. And on this graph, I got that from the fact that we are increasing. So the slope of our first derivative graph tells us the concavity of our original graph. All right, so slope of derivative graph tells you the concavity of your original, and also the value of your second derivative, if it's positive or negative. So our slope now between -2 and 2 is negative, because we're decreasing. So since the slope is negative, our second derivative is negative, and our original graph is concave down. All right, and then after that point, we are going to switch to increasing on our derivative graph, which means our original graph is going to switch to concave up at 2. And our second derivative graph is positive there. We've got all of our characteristics that we need now to construct our graphs. So first, let's look at the graph of the original function. It's going to switch from decreasing to increasing at -4, and it's concave down there. So I feel like I made a mistake. Oh, it's positive second derivative. I did make a mistake, I'm sorry. This should say concave up. All right. So on our graph of f, we've got a maximum there because we're going from decreasing to increasing. So I've got a critical point, all right, and I'm going from decreasing to increasing. And then at -2, I've got an inflection point. I'm changing from concave up to concave down. And I am messing up this graph like crazy. Sorry, I am doing terribly this morning. So I'm gonna blame it on a lack of coffee. So we've got -4 is our critical point. We're going from decreasing to increasing. So our graph should look like this. It's concave up until -2. So at -2, we have another point. We're still increasing, but now we're concave down until we get to 2. So I'm concave down until I get to 2. And at 2, we're continuing to increase, but we switch to concave up. So that's our graph of f of x. All right, our second derivative graph, we've got -2 and 2 is the spots where our derivative equals 0. Second derivative equals 0. We're positive to the left, negative in between, positive after. All right. That's all, folks.